Last but not least, a word problem with rates. When I started teaching AP Calculus AB and looked at FRQs, this was the FRQ type where I was struggling most to understand what they were asking from me. I was very willing to do it, but it was not always easy to guess or see through their intentions. The questions are pretty difficult and a little bit unnatural, I'll say. It's a word problem, it's supposed to be real life, but it's not always very natural. Anyway, let's have a look at the introduction to the question. A hive contains 3,500 bees at time t equals 0. During a 4-hour time span, bees enter the hive at a rate modeled by E, where E is measured in hundreds of bees per hour. During the same time interval, bees leave the hive at a rate modeled by L, where L is also measured in hundreds of bees per hour. So, there's a few things we can talk about here. First of all, notice that E stands for enter and L stands for leave, so this helps us not mix these two functions up. Secondly, the units are a little bit strange. 3,500 bees, so at the beginning there's 3,500 bees, but you should stick to this number 35, and the unit is hundreds of bees. Now what it means for the rates is that the rates are going to be hundreds of bees per whatever the unit for time is, and here it's hours, so hundreds of bees per hour. Using units and always referring to units in these word problems with rates is very helpful, I think, in understanding or knowing what we're going to have to do. Alright, so let's see question A. How many bees leave the hive during the time interval from 0 to 2? How many bees? We will answer in bees or hundreds of bees, and therefore we will need to use the leave function and integrate it, because this is a rate and its units are hundreds of bees per hour. If we want to go from hundreds of bees per hour to hundreds of bees, we need to integrate. So that's, I think, not too hard. We integrate from 0 to 2 L of t dt, and it's a line. So integrating that is not too hard. The integral of negative 2t plus 15 is negative t squared plus 15t. We use the fundamental theorem of calculus and we get 26. Student A does a nice job of always explaining that this means 2,600 bees or 2,600 bees. So setting up the integral correctly was 1 point, and finding the answer was 1 point. Oh, sorry, integrating was 1 point, and finding the answer was 1 point. So nicely done, and 3 points that can quite easily be earned. It's not always that easy in these word problems with rates. Student B did the same setup, so great. They also integrated correctly. And then there's a sad mistake here. The mistake is not that they didn't simplify the arithmetic. This would be perfectly okay to just give the answer like that, but it should be negative 2 squared, and I think that student integrated without consciously doing it and then still squared, so that number would not give 26. Anyway, 2 points out of 3. Finally, last student integrated correctly. There's a dt missing here, but anyway, that's fine. The integral is also correct, but somehow they got negative 26 bees instead of 26. It's always the same. If you get an answer like that, don't hope it's going to work. Just think about, why am I getting a negative number of bees? Can it make sense? Certainly not. If it was a rate, that's okay to have a negative number of bees per hour, because that would just mean the number of bees is decreasing, but negative 26 bees in and of itself doesn't mean anything. Also, We know that the correct answer is actually 2600 bees, not 26 bees, but it looks like in other exercises that the graders did not take points off for this unit mistake. Question B, write an expression involving one or more integrals for the total number of bees in hundreds in the hive at time t from 0 to 4. Find the total number of bees in the hive at t equals 4. This was a high-stakes question because solving it really helped for question B and also for question C later, so messing it up here was quite costly. This is the correct expression. The number of bees is the number of bees I have at the beginning, which is 3,500, and integral of the number of bees who enter, and then I subtract the integral of the rate at which they are leaving. This is from 0 to 4. So nice. And this pattern happens a lot. You have the initial value plus what is increasing minus what is increasing. It's exactly the same if it's a word problem with a tank that's filled up with water and leaking at the same time. You would write how much water is in there at the beginning, how much is pumped inside, and how much is leaking. So that said, we can now calculate b of 4, or the student gave a name here, that's great. B stands for B, I guess. Later I'll show you something where I wrote n of t, or n of x, so the number of b, but it's in any case, it's really nice to invent a name when it's useful. So b of 4 is 35 plus the integral of 16t minus 3t squared, that's a polynomial, it's not too hard, minus the integral of negative 2t plus 15 that we did earlier, and in the end we find 55. Therefore, 5,500 bees are in the hive at time t equals 4. 1.4 setting up the integral correctly, 1.4 finding the integrals, and 1 point for the final answer. Student B, same correct setup, initial number plus the bees that go in minus the bees that go out, and when we plug this in, we find an expression like that. So this time we notice that the student stopped before solving the arithmetic. The answer is actually very long. It's 35 plus 8 times 16 minus 4 cubed minus 0 minus negative 4 squared plus 15 times 4 minus 0. This is correct, and therefore the student earns the point. Last student mistake from the beginning. This is the number of bees. The integral of that is the number of bees that enter the hive minus the integral of the bees that leave the hive. That is correct, but we forgot the 35 plus here because we start at 35. So this integral should give us a value of 20 in the end. And this 20 means what is the difference in the number of bees between t equals 4 and t equals 0. 35 plus 20 would give us 55. So that student then proceeds to find the integrals correctly and makes a mistake later and gets 0. If you wonder where the mistake is, it's right here. 8t squared, so 8 times 4 squared is 128 and not 108. So if that had not been a mistake, we would have had 20 down here. So as for points, the first point is not earned because we're missing the initial value 35. The second point is earned because the integrals are correct, and the last point is lost due to an arithmetic mistake. Finally, question C, find the minimum number of bees in the hive for t between 0 and 4 and justify your answer. So student A starts by setting this up. And that's correct, and by the way, it's worth 1 point already. There's two ways of really analyzing what this means. The first is just to reflect on what these two rates are. This is the rate of bees that enter, and this is the rate of bees that leave the hive. So let's imagine for a moment that L of t was greater than E of t. What it means is that there's more bees leaving than there are bees entering. So logically, that could not be the minimum if we were in such a situation. If there's more bees leaving, then the number is currently going down and the minimum is still to come. So if L of t was greater than E of t, it would not be the minimum. And likewise, if L of t was smaller than E of t, it would mean that more bees are entering than bees that are leaving, and that means we probably passed the minimum. The number is going up, so the minimum was earlier. So if we look for the minimum, we want a balance between E and T. We want E of t equals L of t. The other way of thinking about it is to go back to the equation for the number of bees that we have in the hive at any time x. So I called it n here, and we saw 2 out of 3 students got this correctly, that n of x equals 35 plus this integral minus that integral. When we look for a minimum, it's always the same. We want to find when the derivative equals 0 or when the derivative is undefined. So what does it mean in this particular case? It might be a little daunting to take the derivative of this huge thing, but I'm still showing it to you because there's value in seeing what happens. N prime of x, so the derivative, I want to figure out when this is equal to 0 or undefined. N prime of x is the derivative of this huge thing on the right, which is the derivative of 35 plus the derivative of this integral minus the derivative of that integral. So if I write it here, I have the derivative of 35, and that's a constant, so the derivative is 0. Here, the derivative of the integral, I notice that I have a constant at the bottom, x at the top, so it's going to cancel out nicely. Likewise here, derivative of integral, I have a constant at the bottom, I have a variable itself at the top, so it will cancel out nicely. Next line, 0 plus e power x plus e of x minus L of x. And we want this to be equal to 0 or to be undefined. Undefined is never going to happen because e is a quadratic function, L is a linear function, so they will always be defined. And so we just have e of x minus L of x equals 0. This is what the student got. So I just wanted to show this work. This is where it comes from if we really want to do it formally. But I think the instinct of understanding this equality is okay enough, and we don't need to go through this work. Alright, so let's go back to the student's work. Now they need to find when this equation E of t minus L of t equals 0. Substituting the two functions gives us this, and we can put like terms together, factorize, and find that either t equals 5 or t equals 1. Now, because we are actually focused on the interval 0, 4, the value t equals 5 should be discarded. The student now comments on the fact that the minimum is going to occur either here, which he calls the critical values, or at the endpoint. It could be that 3,500 bees is the minimum. We saw that we start with 3,500 bees. That could be the minimum. The number of bees at the other endpoint, at t equals 4, we found in question B that it was 5,500 bees. So this certainly is not going to be the minimum. So we still have two contenders. Is the answer going to be t equals 0 with an answer of 3,500 bees, or is it going to be t equals 1? And we need to check. So I have a second page for the continuation of this work by the student. They made a very nice, neat table here with all the candidates, t equals 0, t equals 1, and t equals 4. 35, we knew it from the very beginning. 55, we calculated it in question B. And now we still need to find this number. It's written 28 here, but the work is actually presented there. I wrote this as n of x. The student called it b of t. Everything's great. They substituted t equals 4 minus t equals 0, and the student got 28. This is how we know that 2800 bees is the number of bees at t equals 1. So now by just comparing these three values, we can conclude the minimum number of bees is 2800, which occurs at t equals 1, because t equals 1 is a critical value of b of t, and there are less bees at t equals 1 than at the endpoints. Excellent job by the student. Student B starts right away with very much the same expression. We wrote it as E of t minus L of t equals 0 earlier. This is the same as saying E of t equals L of t. The two rates are balanced. And when they solve, they set this up correctly. They even reached the correct factorization here, but very sadly, the student thinks that it's t equals 5 or negative 1, and this minuscule mistake here yields to earning no point at all in the end. Both of these values are not in the domain, so the student ignores both of them and only compares 35 and 55. And the student comments that there is a minimum number of bees in the hive at t equals 0. Had that student noticed that the correct answer is t equals 1, this is when this is 0, they would have put a 1 here and they would have figured out there was a 2800 bees at t equals 1. So, little mistake, big consequences. Finally, we get to student C, who starts by using the two rates correctly. They don't write equals 0 here, but I think very quickly they make a mistake. I'm not sure why the student from here takes the derivative. We would get into a bizarre concept of hundreds of bees per hour squared, so how fast the rate is changing, and this is just irrelevant. So nothing much to say here about the work of student C. I hope this helped. These word problems with rates are quite difficult to decipher, so the more we practice, the better we'll do. Thank you.